Welcome back, everyone. So we are now working on our second part of calculating the pH of solutions, and today we're going to talk about bases. If you've missed the acid part, that is chapter 16, video number 3. And so this is a continuation of that one. So just to review, when you are calculating the pH, there are really 4 steps that have to happen. You first have to determine if the species is a strong or a weak acid or a base. Step 2, you have to write the reaction that is occurring and the K expression if applicable. Step 3, you have to find the equilibrium concentrations of the hydronium ion or the hydroxide ion. And step 4, you need to find the pH. You might have to calculate the pOH before you can do this. Okay, so we're going to work on, I've labeled this example number 3 because this is a continuation of the previous video. And so our first example is what is the pH of 0.01 molar methylamine, which is CH3NH3. And this is a solution, and the methylamine is dissolved in water. And it has a Kb value of 4.4 times 10 to the minus 4. So, step 1 is to determine if methylamine is an acid or a base, strong or weak. So, methylamine is an amine, which means that it has this nitrogen with lone pairs, and we talked about earlier that this acts as a base. So now we have to decide if this base is strong or weak. And since this is not one of our strong bases, remember our strong bases are things like sodium hydroxide, hydroxides or oxides. Since this is not one of our strong bases, we know that it has to be weak. So we now know that we are working with a weak base. So now, step 2 is figuring out how this base reacts with water. So I have methylamine, which is a weak base, and so in water it is going to form an equilibrium. And remember that bases accept protons, so this is going to become CH3NH3 plus OH minus. And the Kb for this reaction is given to us in the problem. So now we need to find the equilibrium concentration of H3O plus or OH minus. So H3O plus equilibrium or hydroxide equilibrium. And since in our reaction we're working with a base, we produce hydroxide, that is how we're going to decide that we want to find the equilibrium concentration of OH minus in this example. So since we have an equilibrium, we're going to set up an ice table. Oops, this is supposed to be 2. I'll fix this up here. Plus water is an equilibrium with CH3 NH3 plus OH minus. Initially, we have 0.01 molar of this. We don't care about water, and we have no products to begin with. And so that means that the reactants are going to disappear, and the products are going to form. And so at equilibrium, I get 0.010 minus X, and X, and so I can set up my expression that 4.4 times 10 to the minus 4 is equal to X squared over 0.010 minus X. So to do this, we use the quadratic equation or the approximation, and we find that X is equal to 1.89 times 10 to the minus 3 molar. And this is equal to the concentration of hydroxide at equilibrium. So now we're ready for step 4, which is find the pH. So to do this, what I'm going to use is the relationship that pH plus pOH is equal to 14, and pOH is equal to the minus log of the hydroxide concentration at equilibrium. And so I know the concentration of hydroxide at equilibrium. That's what I just found. So the pOH is equal to the minus log of 1.89 times 10 to the minus 3 molar, which is equal to 2.72. So now that we know the pOH, we can find the pH, because pH plus 2.72 is equal to 14. And so that means that the pH is equal to 14 minus 2.72, or is equal to 11.3. Now, to sanity check this, remember that we said that this solution was made up of a weak base. And since it is a base in solution, we would expect that the pH is greater than 7. And so when we get our answer, we want to sanity check and make sure that it makes sense. And so since 11.3 is bigger than 7, we are confident that we have a base, and this answer makes sense for us. Okay, so now let's do another example. I'm going to walk through the same 4 steps on this example again. So we have I'll back up just a sec. So the example is, what is the pH of 0.010 molar barium hydroxide solution that is in water? And so step 1 is determine if this is an acid or a base, strong or weak. Okay, so the first thing I ask myself is acid or base? Well, we learned last semester that things with hydroxides, these OH minus, these are bases. And then the next question is strong or weak? And barium is in column 2 on the periodic table, and therefore this is a strong base. So now step 2 is figuring out how the barium hydroxide reacts with water. Since it is a strong base, it is going to fully dissociate. Notice that this 2 in front of the hydroxide, it is because there are 2 hydroxides for every 1 barium. Now, you might be asking yourself, where did the water go? The water is still hanging out in the product side. These are aqueous. And so that means that the water is participating by hanging out around them and keeping these ions in solution. And so really the water is not closely involved in this reaction. And that's true for all strong bases. The water is there as the solvent. Okay, so step 3 is find the equilibrium concentration of hydronium or hydroxide. And since we're working with the base, we want to find the concentration of hydroxide in this case. And since we are working with a strong base, to do this, we are going to use stoichiometry. Now, To use stoichiometry, we have to have moles and not molarity. And so what we are going to do is we're going to assume 1 liter of solution. This is a fair assumption because our concentrations that we get out are going to be the same because we're not changing the concentration during this problem. And so we can just pick a volume. So we want to find, I'm going to work to find moles of barium hydroxide. And so to do that, I'm going to take my 1 liter of solution and I'm going to use the molarity of that barium hydroxide where there's 0.01 moles per liter. And this gives me 0.01 moles of barium hydroxide in my solution. And so now I can use stoichiometry and figure out that convert from my moles of barium hydroxide, where 1 mole of barium hydroxide reacts to form 2 moles of hydroxide. And so at the end, I have 0.02 moles of OH minus. So that doesn't quite help me because I want to find the concentration of OH minus instead of moles. But we know that molarity is the moles divided by the volume. And so I've got 0.020 moles divided by my volume, which is 1 liter, which gives me 0.02 molar hydroxide in our solution. So now I can move on to step 4, which is finding the pH. And I'm going to use the relationship that pH plus pOH is equal to 14. And so to do and that pOH is equal to minus log times the concentration of the hydroxide ion. And so this is minus log of 0.020 molar. And so the pOH is equal to 1.70. And we know that the pH plus 1.70 is equal to 14. And so the pH is equal to 12.3. And sanity check. We have a strong base. Therefore, the pH should be greater than 7. And that is the case. So I am happy with our answer. Okay, so from here, you should now be able to go practice some problems finding the pH of weak acid, weak base, strong acid, and strong base solutions. I recommend you go look at the problems at the end of chapter 16. You can also look at some of the homework problems and the practice problems that I have posted for more examples like this. But go see if you can do some of these problems. Remember that I have office hours and answering emails, and that these resources are all available to help you with this material. I will talk to you later.